All right, this is chapter 8, number 14. And we are told that a sled is given a push from the bottom of the slope. Do drawing. And they tell us how steep the slope is. They give us theta. And here's the beautiful sled. So it goes up and then it stops at a certain point. Now it tells us the height. I'll label that as the y-angle. It tells us is we'll get to that in a minute. We can do a free body diagram. Notice that it's just the body, that there's nothing else underneath. So there's the force of gravity. And there's the force of perpendicular to the slope. And we have theta. Now, let's see what else they give us. They give us that the height that it reaches is 1.12 meters. All right. The initial would then be okay. The initial would be 0 meters. Gravity is 9.0 meters per second squared. And the initial is actually what they want us to find. But in a push, then at 1.12 meters high, its final velocity is 0 meters per second. It stops. So we are going to use the conservation of energy. So let's U, okay, initial kinetic energy plus energy, gravitational potential energy, equals final kinetic energy plus the final gravitational potential energy. So it started with push. It's having motion. So there is a number, but its height, its initial height was 0. So this whole term goes to 0. This is the top point where it stops moving. Since it's moving, this velocity, the velocity is 0. But this kinetic energy also goes to 0. But it has a height and it stays have number. Alright. 1/2 m v initial squared equals mg final. Once again, it didn't matter how heavy lead was. We can divide that out. And once again, I'm referring to a problem. Nothing. We want to find the initial velocity. We do the algebra and we find it's the square root of g y final. We plug in the numbers. So of 2 times 9.8 meters per second squared times the final height, which is 1.2. So then that, what that comes out to is 4.68296149 meters per second. Now, taking into account significers, there is 3 significers. This is the only thing we used that they gave us. They gave us the slope, but it really doesn't matter when we use conservative energy. We don't need to rely so much on trigonometry. Frequently we don't need to. Sometimes we, in this case we don't, because we knew exactly what the height was. Alright, it's 1.12. That's 3 significant figures. That would be 4.69 meters. And there's your initial velocity.